More questions. Okay. Before we do 6 and 7, I want to go through with you some of the tables of linear regression. So if you run linear regression, there are a few tables that are important. Okay. So first we have this model summary table. This gives you two pieces of important information. One is the correlation, another is the R-square. So whenever they ask you the percent of variation, that's R-square. And then we have the ANOVA table. The ANOVA table, it's similar to the one-way ANOVA table we saw before. Here, the p-value here is testing whether beta 1 is significant. And then we have the coefficient table, which is the most important one. So we have the number of beta 0 and beta 1. Here, if every single row is testing whether it's significant or not. For example, for this first row, we're testing whether beta 0 is 0 or not. And we have a small p-value, which means beta 0 is significantly different than 0. Similarly, here, the second row, we're testing whether beta 1 equals to 0 or not. And we have a small p-value, which indicates that the GDP has a significant impact on the internet use. You will find the p-value here, for example. The p-value here in the F table, here I have 2.63 something. Is exactly the same as the p-value here for the beta 1, because they are essentially the same test, okay? You will also find that if you do the t-value, the 14 something square will equal to the F value, which also confirm these two tests are the same. Okay, and then let's move on to the sixth question. For the sixth, we're doing the same thing, but we're not using internet over GDP. We're using log internet over log GDP. So if you write out your model, so for example here, 6a asks you to define a model. When they ask you to define a model, 6a, okay, then we are basically copying this, but instead of internet, we have line internet, and we have line GDP, okay? And then we have to run the model, and then we do the similar thing, okay? So to run the model, let's run regression again. So analyze regression, linear regression, and then let's put log internet as y, and then log GDP as x, okay? For the plots, okay, we have both of them to check the assumptions, okay? Let's do okay. So here we have, let's take a look. This one, it asks you to do a scatter plot, including the least square line, okay? It's basically similar thing at 5, okay? But let's do a scatter plot, okay? Scatter plot again. We do a scatter plot, a simple one with line internet as y, line GDP as x, okay? Then we do okay. And then here, in order to insert a line, you double click on the plot, and then you click on this fit line at total, okay? And then you will have this fitted line, okay? Okay, now let's go back to the, here it asks you whether the line provide a good fit. So if you think like the line is close to your data point, then you can say it's a pretty good fit. Like in here, I would say the line captures the main pattern of the data point, so which does look pretty good. The percent of variation. So the percent of variation I have for this model, look at the R-square table, it's about 55%, which is smaller than the one I had before. And again, my data is different than yours, so you might get different conclusions. But they're pretty similar in a sense, okay? Check model assumptions. So for model assumptions, the linearity I think is roughly good. Independence is fine. For the equivariance here, it's pretty uniform, but again, I can see a non-linear pattern here, and also there is a decrease of variance. So I would still say there's a little bit of violation for the equivariance assumption. For the normality assumption, I would say there is a little bit of violation too, because there is a pretty significant pattern here. So I would say after the log transformation for my data set, the assumptions does not satisfy perfectly. Okay, So, and then with part D, is linear regression of any value in explaining can state this in terms of non and alternative hypothesis about the slope. Identify the test statistics, give results based on the t-test and the f-test. Okay. So for part D, we're doing hypothesis testing. Okay. So for part D, for example, we're testing whether beta 1 is 0 or not. If beta 1 is 0, for example, if this term is 0, we have a constant model, which means that GDP has no impact on on the internet. So for the null hypothesis, we say that beta 1 equals to 0. Okay, so no relationship between these two things. For alternative hypothesis, you also have different choices. So here it says of any value. We didn't really say like anything about positive or negative. So we have a two-sided alternative. So we're saying beta 1 doesn't equals to 0. Okay, so a two-sided alternative. And how do we test this? So you can either use the f-test or the t-test. If you use the f-test here, the test statistics is this f value, and the p-value is about 0. If you're using t-test, this is your test statistics, and this is your p-value, okay? And like I said, these two reach the same p-value, and the t-squared equals to f. Okay, and that's question 6. Okay, we have the last question. For the last question, 7a asks you, what is the effect of GDP on internet? Specifically, we have to derive the multiplicative change in GDP by a factor of k. Okay, for k 1.1, 1.5, or 2.0. Okay. So since here we have a log version model, so both of them are on log term. So if you check your notes, you should see some derivation that for a multiplicative change of k in the x, we should be looking at a k power beta 1 change in the y. So for example here, my k, for example, for k is 1.1, the amount of effect I would be expecting will be 1.1 power the beta 1 value. My beta 1 is 0.754, 0.754, okay? And that is how much? 1.1 power 0.754. That's 1.07, 1.07 roughly, and that's the amount of change. And you do the same thing for 1.5 and 2.0. Here it also asks for the confidence. So for the confidence, we need to know the confidence interval of beta. So for this table, I only have the beta 0. I don't have the confidence interval. Sorry, I only have the value, the beta 1 had, but I need the confidence interval as well. So we're going to do that, okay? For question 7b, it asks about prediction. So we're going to do B as well, okay? Okay, so let's do the regression again. So analyze regression and linear regression, okay? So in the statistics option, let's also check the confidence interval, because before we only have the estimate, now we need the confidence interval, okay? For the save option, this is for 7b, because we are making prediction. So let's save the unstandardized predicted value and also the mean and individual prediction interval, okay? Let's do continue and then let's do okay. So again, for question 7, we're using the model in question 6, okay? So first, for the confidence interval for this part, okay? So basically, now we have a larger coefficient table. For example, for my beta 1, I know the interval is from 0.6 to 0.8. So basically, I do the same thing here for the lower and upper bound. So for the lower bound, I have 1.1, 0.0628, okay? And then for the upper bound, I have 1.1 power 880, and these two numbers will be my these two numbers will be my lower and upper bound for the effect here, okay? And then let's look at 7b. 7b is saying that the internet useful count is missing, and we want to estimate the internet use for Canadians. So basically, we know the GDP of Canada, and then we plug into this equation, and then we know what's beta 1, what's beta 0, and then we can calculate what's low in internet, okay? So besides the estimate, we also have to do one thing is called the 95% prediction interval. Is your model correct? Okay, so before I saved a few values, okay? So here I saved the PRE. The PRE is what? If you don't know what this column represents, you switch to variable view, and then for each variable in the label part, it gives an explanation. So, for example, for, oh God, oh my goodness, kidding me. For this one, this is the unstandardized predict value, and then the LMCI and UMCI represents the confidence interval. The LICI and UICI represents the prediction interval. So what we do is we're going to highlight Canada, and then here you see the internet is missing, and our prediction is 5.78 based on my model. That's on the log scale, okay? And then I'm going to exponential this. So exponential 5.78817. That's 15%. Okay, that's 15. No. No. So for Canada, so this is a prediction on the log scale, right? So we have to, sorry, this is a number. I have to do at e power this. So e power, so sorry, 326. So 326, that's my predicted number. And the real number is 545, which is pretty off in a sense, okay? And then for the 95% prediction interval, that's basically these two values, the LICI and the UICI. So basically, let's highlight Canada, and then let's take a look at the interval. At the log scale, the interval is from 3.4 and 8.1. So again, you have to do an exponential here and exponential here to get the original internet use. What assumptions must you make in order to use the model to estimate the result in Canada? So again, we talked about the assumption of the model, right? The assumption, the linearity, independence, equivariance, and equivariance and normality. And especially in my model, I would say both the equivariance and normality assumption doesn't hold very well. 7C asks you to estimate internet use the model in 5A. How does this compare to the actual value? So for 7B, we use the log model to make a prediction. Here, it basically asks you to use the original scale model, the model in 5, to make a prediction. Okay, so and you can do that, and you can compare which model provides a more accurate result compared with the real value. Okay, so that's for question 7. Okay, so this one is really long, but to summarize things, basically we did the linear regression and we did 2 models. For question 5, we did a model based on the original value. For question 6, we did a model on the log transformed value. Okay, and then there are a few related important tables. For example, the model summary table, so R squared, you should know what it is, the ANOVA table, and also the equivariance table, sorry, the coefficient table. And then you need to know what is the normality plot, how to use it to check equivariance, sorry, to check normality, and the residual plot, what is a residual plot, and how to use it to check for equivariance, okay? And that's everything. Okay, bye.